So in this problem here, we are given two coordinates and we're asked a number of questions. This topic is straight line geometry. First things first, I like to sketch this on the side, like so. So point A is 1, 7, and point B is 5, 1. So this one is 1, 7, and this one is 5, 1. That formulates a straight line with a negative gradient because it's going downhill. First of all, it says find the gradient of the line AB. Now to find the gradient, we know this formulates a triangle. The gradient is always the change in y divided by change in x. Another name for the gradient is m. So you can see here the change in y, it goes from 7 to 1. The difference between those two is 6. The difference between the x, the change in x, is 5 and 1. 5 and 1, the difference is 4. Now because it's going downhill, the gradient is negative. Minus 6 over 4 or minus 3 over 2, which is minus 1.5. Hence or otherwise show that the line AB has an equation of this. So to find the equation of a straight line, we use y minus y1 equals m x minus x1. We're looking for y1, m, and x1. y1 and x1 are any of these 2 points. Pick one, whatever one you want, and m is the gradient. I'm going to pick this one here. Y minus 7 equals, I'll put it in fraction form, minus 3 over 2. X minus x1 for that point is 1. It wants it in this form here with no fraction, so I'll multiply everything by 2 to remove that fraction there. So it becomes 2y minus 14 equals minus 3 x minus 1. Multiply this by 2, only that goes because that's multiplied by that, so the 2 goes. Multiply each one of these by 2. Now simplify that, expand the bracket, so we get 2y minus 14 equals minus 3x plus 3. Rearrange it so it looks like that. Move that there, move that there, so it becomes 17. So you get 2y plus 3x equals 17, which is the same as that, except the 3 is at the beginning. It doesn't matter where you put that. Now, part B says the line AB intersects a line with the equation at the point C. So there's another line here somewhere intersecting at a point. Find the coordinates of C. When two lines meet, this line and this line here, we can solve them simultaneously to find the meeting point. So first things first, we need to make either the x's or the y's the same so we can solve them simultaneously. Now let's go ahead and make this x the same as that x. This x here is 3. That x is 1. So multiply everything by here by 3 to make that 3x so we can subtract them both. So start by this one here. The new equation is going to be 3x minus 12y equals 24. Put our old equation here. 3x plus 2y equals 17. And simply subtract them. That minus that is 0. That's why we made that 3x. So we can make that 0. Now, minus 12y minus 2y is minus 14y. 24 minus 17 is equal to 7. Minus 14y equals 7. So therefore, if we go up here, y is equal to minus a half. Plug this into any one of these equations, and it will give you the x value. Let's go ahead and put it into this one here. So we have 3x plus 2, put the y inside there, becomes minus 1 is equal to 17. Move that there, becomes 18. Divide both sides by 3, x is equal to 18 divided by 3, which is equal to 6. So 6 and a minus a half. The final part of the question says and find an equation for the line through A which is perpendicular to AB. Now point A is that point there, 1, 7, and when two lines are perpendicular, if this is M1 and this is M2, then M2 is equal to minus 1 over M1. Our first M was minus 3 over 2. Put minus 3 over 2 in there, it gives you positive 2 over 3. So the final part is going to be y minus y1 equals m x minus x1. It says point A, so we have to use point A again. So the y is 7. We just said the m is going to be 2 over 3 because it's perpendicular, like this, 90 degrees. X minus x there is 1. Now this time it didn't ask us to put in any form, so we can leave it like this.